I can talk directly into the mic if necessary.
Or you can use this one.
Or I can use this one?
Yeah.
Okay. So we talk about FRR a lot. I like to note that I run the nonprofit that actually does all of the work or not all of the work, but a lot of the work in the testing for FRR. So I have this cool shirt. It's a nonprofit that we operate. I've been doing it for about 10 years now. And so in my head, open source is key. Everything has to be open source if possible. And one of the things that we're running into now, since we're talking about all of this, is that SwitchDev is open source, right? It's as open source as you can get. When you do the translation to the SDK, that's kind of open source, right? It's open header, or it's like, it's close to open source, but by the fact that you're not running a daemon in the system to do the translation, effectively you're using the Linux subsystem, it's open. And so our goal has always been to maintain staying open. Now that becomes very interesting as we continue to move forwards, because you'll note that a lot of companies are talking about Psi, right? Some people talk about Sonic and Psi, and some people just talk about Psi. And it's becoming very clear that the industry is pivoting towards Psi as the most generic interface to use. Just yesterday, actually it was today too, but networking at scale at Facebook, right? They had an entire talk just about SAI and the abstractions that they're doing. And so recognizing that that's coming, within DENT, we're trying to think forwards as to what DENT looks like if it consumes Psi. There are two ways to do it. One way is to just literally consume it via an SDK and keep it proprietary. The other way is to attempt to do some sort of a netlink or a translator or hook directly into FRR or however you want to do it, but basically do it open source and talk to Psi. And so we tend to focus that way. This slide doesn't have a lot of usefulness. So the slide came up in Jason's talk too. It's super tiny over here, so I'll move a bit. What did we try and do with DENT? So when DENT came out at the time, we really didn't see any low power, low cost, or cost optimized devices out there that could run another operating system. Most every device, and you'll continue to see it as they get announced, if it's an open or a white box switch or however you want to say it, we'll say that it supports Open Network Linux. But what does that actually mean? That means that, in a sense, you can query things, the fans, the LEDs, all of that stuff is going to work. But it means nothing about actually forwarding traffic or working. And so when we looked at how we were going to handle this problem, and part of the reason I came over to Amazon from Big Switch was to handle it by building the operating system off of Open Network Linux and start there. We know that all of our vendors can write support for Open Network Linux, so we had them do it. They continue to do it. That makes it so that we can bring systems up super fast, right? We're not futzing around and trying to figure out, how does a fan work? Where are the LEDs connected? Where is all of this? None of that. All of that's handled by ONL and the ONL platform driver. And so when we looked at this, we said, okay, well, if you have a closed system, right, you have a vendor who provide both the OS and the hardware, then you're going to have a lot of trouble doing abstraction or running something different on it, right? Whereas if you can separate the two and start to utilize these switches, then you're able to benefit from hardware cost optimization and such. And I can give you an example of a switch that is used heavily around, which is the 4610, which is a 1 gig switch with a tiny ASIC with a tiny ARM CPU on it, right? It's a very basic switch. It's cost optimized. It's not meant to do a lot. But you can actually run what we did here on it, because we don't require a lot of CPU, we don't require a lot of memory, we don't have a lot of overhead. And so when we looked at the problem, we said, well, this is what we see across the company. People are going to expect that it costs less. They're not going to expect that it costs more. They're not going to expect that we have higher standards. They're going to expect that we can meet or exceed the numbers that they were already at. And so, again, we focused on how do we abstract the network OS and how do we make it, I'm not going to say thin because DENT isn't thin, but make it so that it could be stripped down, so that it could be used on a basic ARM switch and it would function well enough to move forward. And so what we ended up with, as we mentioned, are these switches that we effectively asked to be built, right? We went to different vendors. We said, hey, you know, Marvell, NXP, these different people, we said, do you have a chip we can use? What's the cost of the chip? How do we put together a combination? How do we make that combination work across multiple ODMs, right? And so we came up with one, and we stuck with it. And it's worked relatively well for us. So what we ended up with is DENT OS running on top of the switch hardware. And the switch hardware is really abstract to us. We're not that concerned about what the switch hardware is. We're not concerned about, you know, who makes it. We're not concerned about how it's laid out. We're not concerned about most any of that from the hardware perspective. We're only concerned about the functionality as a device. And so what we end up with is the stack where we have all of our tools on top, right? We have a PoE daemon. We actually worked with Delta Networks to get a PoE daemon written specifically for us to work with the DENT operating system on the switches that we use. We have TC. We obviously have bridge control and LLDP and all of that, right? And we use FRR because it's the standard. Now, an interesting side case there, right, is that we could use Bird because Bird does BGP just fine. And we don't do anything other than BGP, but we still use FRR. And that's really just a general, what do you like best kind of a situation, right? And I'm always honest in saying that, you know, I like Bird. I like FRR. I don't really worry about, you know, the connotations of going between the two because it's not an issue. So if you wanted to run Bird on DENT, you could. I'm kind of slipping on my topics here, but the point is that we built DENT so that what you put up there didn't matter as much. How you programmed the forwarding plane, how you programmed the Linux kernel and told it what you wanted to do didn't really matter as much. It was all about how that data got translated down. And I had a use case that we actually ran into with another customer where they said, hey, we're configuring VLANs this way. Will that still work? And the answer is really, what does it look like once it gets translated? And in the end, if it translates the same, then why does it matter, right? It's Linux. and Jason brought it up, and Vincent brought it up, and we'll continue to bring it up, right? Our goal is for it to be Linux, ETH tool, that. Our goal is not to have a lot of extraneous tools that are purpose-built or custom-built to do things. And honestly, our goal, although once they talk about upstreaming, our goal isn't always to put things into the Linux kernel or into ETH tool or add these features in there. Sometimes we do it outside of that. Like PoE is a very good example. There are multiple ways to do PoE, but PoE itself actually requires a lot of polling and talking and how do you say, negotiation and such. Once you've done that, you can actually probably just leave the port alone. If you move that into the Linux kernel, you'll actually be polling it a lot more than you probably should. Now, there are probably ways to work around that, but for us, PoE seemed like more of a pretty straightforward thing. You base it on whether or not the port has come up or not, or down. You do the negotiation, and then you go through and you modify things. And then, of course, on top of that sits the forwarding table, the driver switch dev, the Linux kernel. We attempt to go to the latest LTS. So right now we're on 5.15. Whatever the next one is going to be what's in DENT 4. So 5.15 is what's going to be in DENT 3, and is in the main branch at the moment. And anyway, just to continue on, we don't care here either. Marvell, Mellanox, and Novium, as long as we have an interface to talk to them, we're fine. If they do switch dev right now, we're golden. If they don't do switch dev, we know that as we move forward, we have to find a solution. And so we're working with everybody, and it's kind of nice to be able to be so open and work with different companies. But you know, we're constantly in talks with everybody, and I think even to make a point, when Facebook talked yesterday, they said, well, we couldn't have really done this without the help of Microsoft and Amazon and these other companies who said, you know, we're willing to work with this, we're willing to throw in the money, throw in the help, and try and get these things done. Because in the end, it enables everybody, and it's valuable to us, it's valuable to you. So mine actually still has my email address in it, which funny problem, but initially they misspelled my name. And it took me about 2 years to get it fixed. And now that it's fixed, people still send messages to my old name, which luckily the alias still works. But anyway, so questions? Probably.
You're going to tell us what was the mix-up? So what was the wrong username?
Oh, Nobel.
Yeah, all right.
So. Correct. ONLPD is not. And so what the box with ONLPD is trying to say is that we bypass, you know, anything else because we talk directly to the drivers and directly to the kernel and directly to the hardware there. But go ahead.
Okay. So the question is the Netlink network stack. They essentially are Linux kernel cards, right? Cards Linux kernel.
Right.
And whenever routes get added, right, it basically reflects in the tip of the Linux kernel.
Correct.
That essentially gets programmed through the switch step. So
It's a tricky because the picture will never be accurate, right? You're going to have the entry come in via FRR. It's going to go into the forwarding table. And then from the forwarding table, you'll get netlink messages because of it. You'll grab those netlink messages and then.
I mean, if it's switched up, if it's in FTP,
No, understood. Like I said, it's a tricky subject. Because I have to, as I think forwards about everything with SAI, with these other things, it's like, well, now you actually have to pay attention to the net link messages. Could you would pay attention to the switch dev messages? You could, but again, the whole thing gets really fuzzy really fast as soon as you start to say, I need to support other vendors that don't do switch dev. Okay. Other questions? I think Darius will actually talk. And so